All right. So, any questions about anything so far? Okay. So, in case you missed the last one, what do you need for Java is the Java development kit, right? You Google JDK, right? You go in there and you download the version that you want. So, you click that link, you go to the download JDK, right? You click the accept license, and you pick the file that's for your computer, right? So if you have Windows, pick the Windows one. If you have a Mac, there's a Mac version too. Okay. And then once you install the thing, there's a couple of things you have to do, which is how to set up path in Windows. You have to do that if you have a Windows computer. If you have a Windows 10, click on this link to show you how to set up the link for Windows 10. Here, I'll click it so I can show you. All right, so you basically download the Java development kit, right? You pull all that stuff, you install the thing, right? And then you have to set up the path. How do you set up the path? First, you have to find out where Java was installed. Usually, it's going to be in your local disk. It's C. It's either going to be in here or here. Let's say it was in program files. It's going to be under Java. And then what you have to do is you go Java, then there's going to be a folder called JDK blah 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 something. This is the version of Java that you downloaded. And then in there's a bin folder. And you got to go into the bin folder, and you have to tell, in that bin folder is where the compiler for Java is saved. Okay, what's the Java compiler? That's what turns your code that you're going to write into a machine program. Okay, Windows by default does not know where that thing is. So you have to go and tell it how to do that. So basically you copy this path right here. That's the path to this. Copy it. You click the Windows button, edit the system environment variables, which you open up by just typing env. Then this thing is going to pop up. You click that, right? Then this little window is going to open up. You click environment variables, and then you're going to click this. There's a path, or actually you go to the system variables under here. You click path. You click edit, and then you're going to paste the path that you copied from that previous step in here. Hit the OK button, and now it's done. Okay, and then you can open up the command line in Windows and type Java C, and it'll tell you, okay, it knows what Java C is, otherwise you can't compile. Okay, you have a Mac, you just install Java and it works.
Oh, really?
Yeah. Okay, in fact, if you have a Mac, Java is already pre-installed on your computer. So if you can go to the command line, open up the terminal, type Java C, which is, let's say I open a terminal, right? And if you have Java installed, you type Java C, and it will show all this text. And if it doesn't know what Java C is, you gotta install Java, which is really easy on a Mac. Okay, so that's the installation part. Once you have the Java C going, then you can compile. With Java C, you're going to be compiling your programs. Okay, so what are the things that I showed last time, or it's posted right here in these notes, which is actually a zip file. All right, if you open up this thing, right, this is the lecture. These are the different things I did last time. Okay, so this was the first one. Okay, it's a basic program, and I have this thing in my, this is in my downloads folder. That's where it goes. So why don't I just grab this thing and put it on my desktop? Okay, so then I'm going to go to the, I'm going to close this, don't save. I'm going to close this too. Okay, so I'll open up this here, and I'm going to go through the different things I did last time. So first, I'm going to go open up my terminal, right? And where'd I go? That's right here. Okay, so I am going to go to CD desktop, hit tab, and this was lecture something, so I go CD lecture 06 20, and then it automatically recognizes the rest. CD tells it change directory, so I'm in there, so I'm on the desktop and lecture. I can do ls to show the files, and these here files are the same files that I have here. Okay, so I'm going to show you how to compile these different files. So first of all, double click this. This is my program. Okay, and I'm going to go back to my terminal, right? And every Java program has to have a class, And the Java class, to keep things simple, has to match your file name. So notice this is first.java, this is class first, right? So that's how you have to save it. So if you have a new file, I'll show you when I'm doing this today. You have to save it as whatever the file name is, whatever the class name is, .java. That's the file name you're going to have. Okay, so to compile, and I wrote it here, what you're going to do is you're going to go in there and you're going to type javac first.java. Okay, and you hit the enter key, and if it's compiled successfully, it will not give you any messages, any error messages. If you look at here, if you look at this, by compiling it, it actually created this file. So if I delete this, I'm going to delete it. I'm going to go back to my terminal. I am going to hit the arrow up to bring back the last command I entered. Hit the enter key again, and now I made the class again, right? .class. Okay, so that's the first step. If there is any kind of an issue with your program, let's say every program is supposed to have this. You're going to have class first. You're going to have your public, static, void, main, string, square brackets, args. It's just like your int main in C++, just with a few more words in there. Okay? Then the system out print line, that's how you do a cout in Java, right? This is how you do basic output. Okay, so what I'm going to do is I'm just going to mess with this thing a little bit. I'm going to break the syntax. So this thing is supposed to end with a semicolon. I'm going to get rid of the semicolon. Now this thing in Sublime shows me a little circle, so I have to save it. Now it's saved. I'm going to go back in here. I'm going to try to compile it again, and it gives me an error message. And notice how in the command line it points to the right place. So it tells you, okay, hold on. At line 15, that's the line, there's a semicolon expected. So the error messages you get in this thing are a lot more user-friendly than C++. You'll pretty much narrow it down for you.
So you have to get used to using the terminal a lot with Java.
For now, I would like you to be able to do this in the terminal because it's not that complicated. Plus, if you can do this from scratch, basically, that's what I want you to be able to do. Just you can write your program in a basic text editor like Sublime, and run it from the command line. You can do that in any machine, right? You don't have to install Eclipse or IntelliJ, IDEA, or any of these other fancy, more complicated things. Okay, so let's just do the basics. So, all right, I need to go and fix this thing here. So I'm going to go put a semicolon. I'm going to save it. I'm going to go back again. I'm going to compile it again. Now it's happy. Okay, so you have to compile every time before. If you ever make any kind of a change to your program, you got to compile again first. Okay. Now the next thing is, how do I run? I type Java first. That's it. I'm not going to type .java because that's going to mess it up. Okay, so just Java first. So this first piece is I compiled and I created this file right here, the class file. Okay, the next step is I'm going to do Java here. So this is the part where we're going to run this class file. Okay, so I just hit the enter, and there you go. It shows you the program output. Okay, the program output is some message that we show on the screen. How do we do that? System out print line is how you show something on the screen in Java. Okay, so for now in the beginning, we're going to do a couple of these just from the command line. And actually there's going to be one that is going to pop up a little window. Right? So Java supports graphical user interfaces very easily. We're going to make a final project, tic-tac-toe, with a bunch of buttons, and it'll be cool. Okay, so what I'm going to do is, so let me explain you a little bit again. The \n means you put a new line. So if I get rid of this here, I'm going to do a Control X, then I'm going to save it. Okay, make sure that this thing here is not a circle so that it's saved. I'm going to compile again. I have to compile again, and I'm going to run it now. And now notice the hello world shows on the same line. So when I do a \n, that tells it insert a new line right here. Right? So save again, compile, run. It's a new line. Right? So this is just the basic output. You're showing some little silly message on the screen. Okay? And the public static void main is needed for every program that you're going to run. Okay, if I accidentally go in there and mess up my main, maybe I want to go in there and I forgot that this is Java and maybe I'm thinking C++ still, right? I'm just going to leave it like that. I'm going to save it, save, go back, compile again. And now I'm going to try to run it. So compiling is okay, but now I'm going to try to run it. Right? Oops. Look what it tells you. Error main method not finding blah blah blah. And it tells you, please define the main method as, and it tells you what it wants. It's very neat, unlike C++. Alright, so I'm going to go in there and undo this thing. Alright, now I'm going to save my program again. Now I'm going to go in there and I have to compile again. I'm going to run again, and there you go. Now it works. Okay, so a basic component of every program is, for now, or for a while, you have a class. The class name matches your file name, .java. You have a public static void main, and inside the main, you're going to have some other things. For now, we're just keeping it simple with a print line. Okay, so that's that. Questions? All right, so that was the first thing I showed. I'm going to go in there, I'm going to delete the class file because we're not going to use it for now. So there were some assignments that were asking some questions. So for example, let's go to this exercise 1.1, and I already went over this in the video. You can look at what I did and how I did it. So I'll go through it quickly. So this is the first one and that's what I said, that if you don't have the book, I typed up the exercises, so this is from the book. You don't need the book for now. So the first exercise is define the following terms: computer program, programming language, high level, low level, machine language, assembly language, procedure-oriented language, object-oriented language, source program, compiler, assembler. Okay, all these things are in the book. You can also Google what's what and then answer it that way. I'll basically tell you.
You want definitions?
Huh? Yeah, just different definitions for these, right? And you can Google Google these and give me some kind of an answer. Okay, but it's also going to be in the book. Okay, so what's a computer program? Just instructions that like the one I just wrote right now, telling the computer to do something. Programming is just the act of writing that. Programming language, there's different programming languages to write computer programs. There's Java, there's C++, there's Python, there's all kinds of different ones. Different languages are better for different purposes. Okay, high-level language is the one that mimics more human language. It's easier to write. Java is a high-level language. Low-level languages are things like assembly. That's one of these here, assembly language. That's the lowest level that we humans can write in. Assembly language is very tedious. You have to tell it, grab this little piece and from the processor and put it in memory, then get this little other piece from memory and put it back into this other registry in the processor. So just for me to write this little hello world program that I had, I'm going to have to write, a whole bunch of code, right? So for me to write this little thing, I'm going to have to write a wall of text in assembly language, which is going to suck for two reasons. Number one, it's hard to write. It doesn't mimic human language. Right, so it's hard to write, it's hard to figure out if something's wrong with it. If you get an error message, it's not going to be like this, neat, telling you, oh, there's a missing semicolon, or you forgot the main. You better know the assembly language so that you can figure out why it crashed, basically. Okay, or why it just didn't work. Now, what else? So that's the assembly language. Machine language is one step underneath the assembly language. That is something that only the machines can understand. Right? We're not going to write in machine language. Machine language is just a bunch of ones and zeros. The high-level languages like Java get compiled, and then after they get compiled, then they get interpreted or assembled into lower-level languages, and into machine language. Okay, so Java is an interpreted language, which means the interpreter is going to read this file. So, for example, we had this here. So if I do Java first, right, then I have my class file, right, my class file, and then my Java interpreter, which is the Java virtual machine, is going to go and it's going to read this class file and it's going to execute it line by line, which is slower than a compiled language like C++, where you have an executable file. Right, the executable file, you just double click it and it works. Right? You don't need to have C++ for the executable file to work. It's an executable file. You just run it. For Java, in order for me to run this class file, I need to have Java installed. And by Java, I mean the Java virtual machine. Okay? So the Java virtual machine is the interpreter. which is going to read this thing line by line and turn it into a machine language. Okay? So that's the deal. Procedure-oriented language versus object-oriented language. Procedure-oriented language is C++, or in the beginning of most of the class in C++, what we did was, let me go back to this first. So in C++, you have, right, so this is, let's give you another example. So this is procedure-oriented language, right? You would have, like, let's say you have int procedure, like that, right? And then underneath it, you have int main. Okay, that's a procedure-oriented language. This is just out on its own in the world, basically, right? It's not bundled up into something else. The object-oriented language is something like Java, right? So how would that be different? You basically just have the same thing. You have a procedure, but that procedure is now part of a class. Okay, that's the difference between the object-oriented and the procedural language. Okay, in the object-oriented language, procedures are bundled up into a bigger thing called a class, which is the actual object, and that's it. Okay, that's as simple as I can make that definition. Okay, procedure-oriented, object-oriented. So you can use these. You can watch this video and answer the questions the way you're hearing me say it, if you want, or you can Google the things. Okay, so I'm just going to save this, and I'm going to take this out here. I'm going to just comment it out, save it, and close this thing. Okay, so that's what's procedure-oriented, object-oriented. What is the source program? The source program is the code we write. Right, so this code that I write in here, that's my source program. The compiler is this Java C, which turns my source code into an actual machine language. Okay. All right. So then the next one was exercise 1.28. Assume that you are to create a plan for a Java program that simulates a selection. I'm going to close this. Where is it? The selection of a state lottery that randomly selects 4 numbers. Okay, and it's asking for this plan, list the data and a set of methods that will be useful for such a program. Okay, so let me show you an example for this that I did last time. So we're doing lottery, right? So I made a file called lottery.java, and inside that lottery.java, I'm going to have a class lottery, right? Because the file name .java has to match my class name. Okay, so it's asking me for 4 lottery tickets. So that means I'm going to come up with numbers, right? Numbers are one of the data types that we can store into our program. Other than numbers, there's also words and characters and stuff like that. The numbers themselves can be integers, floats, doubles, right? What is an integer? Integer, same thing as a C++. 1, 3, 5, 6, just the whole numbers. That's an example of an integer. Float or double is a decimal number like 3.14, 1.234. Right? These are decimals. Okay, so since they're going to be lottery tickets, it makes sense for it to be an integer, right? A whole number. And I'm going to make 4 of them. Okay, these things that I make up here, n1, n2, n3, n4, are just variables, right? Variable is just a word I make up to store information. Okay, and that's that. So these are my data items, right? The data items are the variables that I make up. Okay? Now, what are the methods? And by the way, there's a few rules for these variable names. I'll get to them when I get to them. Okay? But for now, right? So these are my variables. These are my data items. What are the methods? Methods are what we used to call functions. In C++, we also call them procedures. That was the procedural-oriented versus object-oriented thing, right? So our procedures or functions, when they're part of a class, we call them methods now. Okay? Just another name for basically the same thing. Okay? So what are methods? Methods are ways to change or look at my data. So for every Java program, it's going to have some kind of a data, or it's going to have some variables. You need to have a way to look at them, and you need to have a way to change them, right? How am I going to look at them? I'm going to do a system out print line, and I'm going to show my variables like you see here. So this is the label for the first one. This is the actual variable. This is the label.
What do the plus signs do?
Plus signs put everything together. So this is going to be a label, and this is going to be a variable. So the variable is going to get glued right next to the label. Okay, so in C++ you had it's like the less than sign. Right, so that's the plus in Java. Okay. All right, so this is just a way for me to show the variables or look at them. And then I also need to have a way to change them. So for now, I'm just going to go in there and just give them some random values, 1, 2, 3, 4, right? So this is a method to look at the data. This is a method that changes the data. Okay? So now here's the trickier part. So first of all, in my main, how am I going to create an object? So this right here, so this here is create an object or instance of the lottery type. Okay, so this is my lottery template. Okay, from that template I can make many other lottery things. Okay, so what I'm going to do in here is I'm saying, okay, lottery my object is equal to new lottery. That's just how you make a new object, right? So first thing I'm going to do is I'm going to say my object look. Then I'm going to say my object change, and I'm going to say my object look again. So the first one that I do here, it's going to show you a bunch of zeros. It's going to say n1 is equal to 0, n2 is equal to 0, n3 is equal to 0, right? Because Java by default makes these equal to 0. Unlike C++, which throws garbage at them. So that's another way Java is nicer. So you fill up it automatically makes them equal to 0. So when you look at this, you're going to see a bunch of zeros. Then I'm going to call the change method. So basically I'm saying, okay, make this object, look at this object. Now change this object. Now look at it again. So when I look at it after it's been changed, it's going to show me these values for them. Right?
I don't really get the part where it says lottery my object equals new lottery.
That's just the syntax. Okay, so lottery my object is equal to new lottery is just the syntax. This is the name of the class. This is also the name of the class. This new business is just syntax. That's just how Java does things. The parentheses are also just the syntax. Okay? So this is the syntax. This here is the syntax to make a new object of this class type. And this is just the name of the object. Okay? So my object is the name of the object. My object is the name of the object slash instance.
So it's like the one that you can change, right?
That's the one that I'm going to be able to change. So I'm going to go in there. First I'm going to look at this object, and I'm going to change it. I'm going to look at it again. So I'm going to save this. I'm going to go back to my terminal, and this time I'm going to compile Java C lottery.java. Hit it. Okay, it's good. Then I'm going to do Java lottery, just the lottery. Hit it, and there you go. First it shows you a bunch of zeros. Then it shows you what I did, right? So this one here is this, right? Then I go and I change the thing, and then the next one right here is this one. Oops, the one on top. Okay? So far so good? Okay. So that was basically what this exercise asked for, right? List the data items and a set of methods that would be useful for such a program. Select your own class name and the data item names. So I just made up whatever, right? It doesn't have to be this exact solution. You can make up some other name for the class, some other name for the variables, change them to something else you want, right? Format your output any way you want, maybe show them on separate lines, but I'm keeping it simple, okay? So that was the first one. The next one is, assume that you're to create a Java program that calculates the floor space of a rectangular room. So I'm going to go back in there, and I'm going to close this thing because I'm done with it. Right? So I'm going to go back to my little folder, and I'm going to delete these two classes because I don't need them anymore. And this one now it's asking, you assume that you create a Java program that calculates the floor space of a rectangular room. For this plan, list the data items and the set of methods that will be useful for such a program. Select the name and all that good stuff. All right? So that's the room. So I'm going to make something about a room. So room Java makes a good sense because that's going to be the class name. Okay, so what are the data items for a room? It's a square, rectangle, right? We're looking for the area of the space of the floor. I'm going to have something like width and length, right? And again, variable names are whatever I want to name them pretty much, with a few rules, right? What is this double? Double means it's going to be a decimal number, right? So it's not, instead of just 1 and 2 before, now it's got something after the decimal. There's doubles, there's floats, right? So the double was a decimal number. And then what I'm going to do is, again, just like before, I want to have a method, methods to change and look at the data items. So I'm going to call the one that changes them just C, so we know what it is, right? So that's the method to change things, right? It changes this to this. And then I'm going to write another one, which is to look at the items. And I'm going to just do a system out print line just like before. This is the label of the variable. This is the variable itself. This is the variable of the label of the next variable. This is the variable itself. And that's it. Okay, but now it was also asking for me to calculate the floor area. So other than methods to change and look at the data items, I can also make up other methods to do other things. In this particular case, I'm going to have a method that calculates the area. I'm going to call it area because that makes sense. And you know, the names for these methods are pretty much arbitrary. You can name them whatever you want with a few rules, few restrictions. I'll go over those in a second. And all I'm going to do in here is I'm going to say, okay, we're going to have, that's a bad idea, so I should have used the capital area. So this is going to be capital area because I don't want to name something that's the same thing as my method name. Right? So the area is area here. Okay? And just like before, what I'm going to do is I'm going to make, this is the name of my class, right? The syntax of Java, and then this is the name of my object, and it's going to be equal to a new object, okay? And that's the room, right? So first what I'm going to do is I'm going to look at that room, then I'm going to calculate the area of that room. So when I look at the room initially, it's going to show me 0, 0, right? And then the area of that thing is going to be 0, right? 0 times 0 is a 0, okay? The next one what I'm going to do is I'm going to do the change of the room, which is going to change these two variables to these values. And then I'm going to look at the room again. It's going to show you now different values for width and length. The next thing I'm going to do is I'm going to show you the area, which is calculated by just multiplying the two things and then showing them here. Okay, so if I save this thing and I go back to my terminal, I'm going to do Java C room Java. I'm going to do Java room, run it, and there you go. The first time when I did this here, when I looked at them initially, they're zeros. The next time when I do show area, it's a 0 because length 0 times 0 is a 0. Then I go and I change them. I look at them again. It shows you this. Then I calculate the area and it shows you this piece. Okay? So far so good?
Well, why is it that you're already starting off with like you know how like in C++ functions didn't come until like way later?
Yeah, that's the Java. Yeah, Java we just, in C++ the functions don't come in later. Here's like, I grab you and I throw in the swimming pool and I tell you try to swim. And that's basically the introduction to Java. That's why Java, I recommend taking C++ first and then doing Java.
Yeah.
But it's okay if you haven't done any programming. It's still doable. I took Java as my first programming language. Don't ask why, because it sounded cool. Okay. Okay. That was like in 1999, by the way. Okay. So that's Java, right? So that's like the steeper learning curve. You got to know what the method is, you got to know what a variable is, and then you start using them right off the bat. But it's doable. Okay. So let me add something else in here. What I'm going to do now is I'm going to make another object. I'm going to call it, now I'm going to say room, bRoom, right? Another room object is equal to new room, right? Room, right? And what I'm going to do is I'm going to show you that thing first. So I'm going to say bRoom dot L parentheses, right? In fact, why don't I just copy this whole thing here, right? It's not going to look much different. All I got to do is just change this name. Right? But basically, this is now, it's a different object. Right? This particular example is not going to show you that they're different because they're the same kind of, they have the same properties. But I can change them. I can say, okay, this A room has a 1 by 1. In fact, let me just do another method here. I'm going to say void C2, right? Just something else, right? And I'm going to go in there. I'm going to copy this, so it makes more sense. Paste that in there. All right. I'm going to make this 3.3. I'm going to make this one 4.4, right? I'm going to save it, and then here for my second object. So this is make another object of the room type, right? Another object, also known as an instance. Right? So this piece of code right here is called instantiation. They like to have fancy names. Okay, so we're instantiating an object. And I put it in there. Instantiate an object. Okay? So, all right. So what I'm going to do is I'm going to do broom L. I'm going to show you the area, which is going to be 0 in the beginning. Then I'm going to go and change it to C2. So I'm going to apply the C2 method, right? So I'm going to change the properties of the second room using this other method. Okay, why am I doing that? So that you can see that these now are going to have different properties. Okay, L is for this one, and then the area. So let me just save it, compile it, run it again. So see, this is the second room. At first it starts as a 0. Then I'm showing you, okay, these are the properties of the other object, and this is now that. Okay, so think of objects like, if you have a dog on an object, you can have a German Shepherd. One object is going to be named German Shepherd. The other object, dog, is going to be called Chihuahua or something, right? They're going to have different properties. Maybe this one is a German Shepherd, and I'm going to have like, it's 5 pounds. But maybe later on I'm going to have another object of the dog type, and now it's a grown-up German Shepherd. Still a German Shepherd, but now it's heavier. So it's basically, you can recycle the same thing and just without writing too much code. This becomes very useful when we start doing graphical user interfaces. You have like a window with a button, all these different things. You can just throw objects on top of objects and just change their properties. Maybe this button is going to be red, maybe this other button is going to be green. Maybe the text is going to be different between the different buttons, or the size of them and stuff like that. But I'm not reinventing the wheel. I'm just making the same, just instantiating different objects and just changing their properties. Okay? So that is basically what I did last time. So one thing I want to show you this time is, so there's some rules for the variable names, right? And they're the same as C++, right? So the rules were, first one was can't start, so these are, let me put it in here. So rules for variable names. And by the way, if you missed it, the 2 forward slashes like this are comments. Okay, what is a comment? Comment is just an explanation for what the code is doing. When I run the program, all this stuff doesn't show at all. It's just for us, the programmers. Okay, so you want to have explanations so that if somebody else is reading your code, they know what you did. But most of all, for right now, you want to have explanations for yourself, because when you look at your programs, you wouldn't know what they did or how they did it if you don't have explanation, right? So some of the comments that I would like to see in every program, I show them into that first.java. So every program has to have these comments on top. At the very least, you're going to give me the program name. So let me go back to this. All right, so this is my room. Right, so the name is room.java, program number. If you're getting something from the book, get that, put that in there. Put your name, right? Your name, right? Put a date when you start this thing, when you finished it, right? If it's the same date, put the same date. And description, what the program is supposed to do. Okay, so going back to comments, you have single line comments, which start with 2 forward slashes. And you have multi-line comments, which start with asterisk, forward slash, and end with forward slash asterisk, and end with asterisk forward slash. What are we going to use these for, other than what I'm doing right now? You're going to use these to show me how your program ran. So every program must have, right? I'm going to save this thing. I'm going to go in there. I'm going to compile it again. I'm going to run it. Right? So this is I can just copy all this. I'm going to just copy it, Control C, go back to the bottom of my code, asterisk forward slash, and paste that in there. Okay, so anything that's in between these two is now also, notice how it's gray, that's also a comment. So it's just an explanation showing me how the program ran. So every program, you have to show me how it works. If you don't do this, I take off points because you didn't test your program. Okay, I'm going to assume that you didn't test it, take some points off. You're going to read a little feedback in the grade book. It's going to say, oh, you lost 30% off because it's untested. If you forgot this stuff on top, I'm going to take more points off because you forgot to document your code. The good news is I offer you multiple regrades. So if you messed it up the first time, you go in there, you change it according to what I left you. You resubmit it, I regrade it for you, you get full credit. Okay? And you're always welcome to just email me your code and tell me, hey, does this look good? And I'll tell you, yeah, but you forgot your comments or whatever, something's missing. Okay? So don't have to turn it in for you to get a feedback. Just send it to me if you like first. Anyway, so going back to multi-line comments about the variable names. So can't start with a number. So if I go in there and I put a number in here, that's a problem. If I try to compile the program, I'm going to save this thing and I'm going to compile it. Oops, doesn't like it. Okay, it might tell you something, you know, it kind of narrows it down, you know, see how it's pointing in the beginning and at the end. So it kind of narrows down that, hey, look, there's something wrong here. It's not a very good error message, so you kind of have to know the rules in order for you to realize what you did wrong. So that's the first rule, is no number in the beginning. You can put the number here, you can put the number there. Let me save it. Let me compile it again. Oops. Now the error is that I changed the variable here, but I keep using the variable width there. So what I have to do, I have to copy this and replace every occurrence of width with this. Right? So they have to match whatever I declared. So this piece here is I am declaring variables. So this is the data declaration section. The book calls this data declaration section. Right? You're basically just declaring some words to be of certain data type. So these two words are going to hold data type double, which is a decimal number. Okay, so now if I save this and I run it again, yep, still doesn't like it. Did I save it? Oh no, I forgot my output here. So I got to change this to with 1, save, compile. Still doesn't like it. I forgot to do the calculations. Whoops, copied the wrong thing. Copy again, paste, save, run again, compile again. Okay, so it's okay to run into errors. That's the process. You run into errors, you fix them, you run into errors, you fix them, you run into errors. That's programming. Okay? The more errors you encounter, the better you're going to get at figuring out what they are, the quicker you're going to get at fixing them. Okay? So don't think, oh, I got a bunch of errors, I'm stressing out. It's good for you. Okay? So that's that. The next thing is, so we can't start with a number. You can put the number in between or in the end, no problem. Okay, the other thing is can't have spaces in variables, right? No spaces. If I go in there and say length space, that's a similar kind of a bug. It's going to run into a whole bunch of issues. Okay, so no spaces. The third one is no special or can't have special characters such as any of these, right? Like any of those other than the underscore. So you could use the underscore, right? I can go in there and say, okay, length like that. Of course, I'm going to have to go and rename all these different variables down.
Even at the beginning?
Yeah, you can do it in the beginning too, right? But don't do that. Okay? So no special characters other than the underscore. Okay? So that's the third rule. Fourth rule is can't use reserved words like class, void, right? These things that have different colors, right? This is a reserved word, that's a double, right? Those are some of the reserved words. Okay? Also, don't use, this one is, don't use the same words as your method names. So if I have a method called C, don't go in there and have a variable C, because it's going to get confused about which one's what. Okay? So that's the other one. You know, I introduced these much later in C++, but now you got to deal with all this stuff at the beginning. And last but not least is use meaningful variable names. What's a meaningful variable names? If it's width, call it width. If it's length, call it length. Don't go and call it num1 and num2. Because then later on you're going to be like, wait, what was num1, what was num2? I can't remember. Just call it what it is. Okay, so that's the meaningful variable names. Why? Alright, so that's that. Now, let's go in there. So that was the first one. There was a sample program. So the other assignment that I had for today, or for last time we met, was basically go in there and type up all this stuff. Okay, it was just a basic program. You have a class called hello world. It must be saved in the hello world.java file name. Unit, you have a public static void main. You have a system out print loud hello world. So just run this thing like this. Right, Java hello world. You have to compile it as Java C hello world.java. Then Java, you run it as Java hello world. Okay. Don't even read this here. I messed this up. I don't know what's going on. I don't know why I put this in there even. Okay. But just basically follow the video. Follow these examples. Not what I typed right here. I don't know why I typed it like that. Okay. Second program was you're going to use multiple system out print lines to show different things, right? If you do system out print, that will not automatically insert a new line at the end of the sentence, right? If you do system out println, that automatically inserts a new line at the end of the sentence. So just if you were to just type this up, you're going to see how it works. You're going to understand what happens. And a lot of this stuff is you got to do the hands-on. You got to get your hands dirty. You're listening to me right now, and I know it's going through this year and it's coming out of the other one. Okay? But that's okay. Programming will give you plenty of practice. And so that was the next exercise. So not that hard. Type a couple of programs, get them to work. Okay? Section 1.5 of the book asked you to create a GUI program. What is a GUI? GUI is a graphical user interface. If I go back in here, I created it. I called it GUI. For the GUI, you have to do import javax swing dot asterisk and a semicolon before you can create a dialog box. So all this stuff, J option pane, show message dialog, no, blah, 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 all this stuff, we're not even going to do this until later, okay? But the book shows you, hey, here's an example of a GUI. So what am I going to do? I'm going to show you an example of a GUI. So it goes like this. Java C GUI, Java, run it, no problem, or compile it. Java GUI, just like before, hit it. And ta-da, there's a little dialog box that pops up. This little hello here is this text. This little title here is this. This J option pane warning message is this. And in the assignment I tell you, go ahead and change it to error message. So I'm going to copy this here. I'm going to go back to my code. And I'm just going to change this little piece to error message. So Java knows the difference between these different names, right? So if I just save it, and let me close this little window. Okay. I'm going to compile again, because I changed it. If I change my code, I got to compile. I'm going to run it again. And now, ta-da, the little icon changed. Okay, so you can very easily... There's a whole bunch of them. Yeah, it's in the book. If you look at the book, there's different messages. Okay, and we're gonna do this kind of stuff for our final project. So, but don't worry, we're gonna do GUIs in chapter 9 and in chapter 10, and when we're done with those, then we do the final project. Up to chapter 8, we barely touch the GUIs. There's gonna be some dialog boxes that let you enter things into the program, but they're not complicated. They're basically just like a line like this, and you just change a couple of things in there and it works. Okay? This no business and this other stuff are, again, just things that are built into the language and knows what to do with them. You have to do all that in order for it to work. I personally don't remember all that stuff, so don't worry about it. Just you look it up, you tweak it, you fix it, and it works. Okay? Not important to remember the syntax exactly, as long as you know how to work with the things. So, this was what I covered last time. Okay? So, now the next thing. I'm going to go back to the home page. I'm going to go back to that week 1. Okay? And what I'm going to do is, I'm going to look at chapter 2. Right? There's a summary from the book. I'm going to click this little thing here so it hopefully opens up in my little window there. Alright, so this is pretty much everything that the book covers. I read the chapter, I typed it up, and I summarized it for you. And I do that for every one of the chapters. Okay, so if you still don't have the book, you can read the summary. Okay, and I have a lot of these assignments are, I help you out in the beginning so you don't need the book. Okay, so I already told you about the different data types. We have integers, right? We have floats, the decimals, right? So the int is any positive or negative numerical value without a decimal. You have also characters. There's with char. We're not going to use a whole bunch of them, but basically anything in single quotes is a character. You also have the floats or the doubles, which are just decimal numbers. Float uses 4 bytes. Double uses 8 bytes, which means that the double can be just twice as long of a number. Okay? But basically, they're both the same decimal things. And there's some other things like \n, \b that do special things. Like the \n tells it if you have some text, and then some other text, and then a \n between, this text, and then the other text goes underneath it. Right? The next text goes after the first one when you have a \n in between.
What are the B and the F here?
B is, I think, bold. F is, I don't even know. Yeah. There's a T also for tab. No, not that important. Okay? But bottom line is if you have a / something, it's an escape sequence. So the / tells it there's going to be that letter after it is going to have a special meaning, and that's what it is. Okay. Arithmetic operations, plus, minus, right? You asked what was this plus in between when the system on print line? The plus is concatenation. What is concatenation? You get one string, and you put something next to it, so it turns it into one bigger string. So what was string? Something in quotes. So for example, let me give you an example of concatenation. I'm going to close this one. I'm going to go back to that room again. So let's say I'm going to write this thing in the main, in here. So let's say I have a string. In Java, it's capital. I'm going to have first name, and it's going to be equal to Alex. Right? I'm going to have a string. Second is equal to Stoikov. All right, let me put a little, I'll leave it like that. And then in here I'm going to say string both, right? In here I'm going to say both is equal to first plus second. This here is an example of concatenation, right? Which means adding 2 strings together, right? Add 2 strings together. It's not going to do math with them. It's just going to turn those 2 strings into one big string. So if I do a system out println, I say both equals plus both, and I compile this thing and run it. I'm going to do Java C room Java room. See what it does? It gets the 2 strings and it just puts them, splices them right next to each other. That's the concatenation. So when you do in the print line, when you do a plus, it actually does concatenation. It turns whatever this is, even if it's a number, and it splices it together with the previous thing. Okay, so that's the concatenation business. That's what this is telling you here. Okay, so whenever you have a plus in the system out print line, it concatenates, which is different than this kind of a stuff. So for example, if I go in there and I do, all right, I'm going to copy this. All right, I'm going to go in there, I'm going to do, okay, I'm going to say 6 plus 5 is equal to, and then here in quotes, I'm just going to say in parentheses, I'm going to say 6 plus 5, save it, And I'm going to run the program again. Java. Alright, so see, that one actually does some kind of a math. So it's concatenating. When you do two numbers together, it knows to do math with them. Whenever you do two strings together, it knows to splice them together. Right? When you do that stuff in the print line, this plus adds the number next to the string, so it turns it into one big string basically. Okay, so that's that. The modulus operator, I'm not going to get into that for now, but it's not like division, right? The other ones are subtraction, multiplication, division, modulus, right? The modulus checks to see if there's a remainder. I guess I'll show you. So let's say if you do 8 modulus 3, that's the same as asking how many times does 3 fit into 8? Well, it fits 2 times, right? So 3 goes 2 times into 8, so 8 minus 3 times 2 is 6. That's the remainder 2, so that's what this is. Okay, it's also known as the remainder operator. Okay, 15 modulus 3, 4. Same question. How many times does 4 fit into 15? 3 times. 15 minus 3 times 4 is 15 minus 12, which is your 3. Okay, so that's that. And then the order in which these go are pretty much the same way you would do it in math. Multiplication and division, and this modulus are first. Then it's the subtraction and addition. And then if you have parentheses, those have precedence also. Okay, just like regular basic math. Okay, string concatenation, I showed you. If you have two strings, it turns into one big string. Okay, variables, I already told you. What does it mean to declare a variable? Well, right here, I declared variables. So that's the data declaration section, right? So that means to declare a variable, there's different data types. And that was in the, I believe I put it into the, I'll put it right again. So there's the different data types are integers, floats, characters, strings. The data types are the types of information. So variables are used to store information into your programs, right? What are the types of information? The types of information are also known as data types. And again, the data types are we can have char for a character, string for text and quotes. So a character is anything in single quotes, string is anything in double quotes. You also have an int, you also have a float, you also have a double, right? So we're not going to deal with a whole lot of that for now, but just so you know. So these are the different data types. That's what they're saying here. Here's your declaration of a variable. What does it mean to initialize a variable? Well, you're giving it an initial value. So right here, I guess you could say as I am initialize variables. Okay, so give variables initial value. Actually, that's not where it's happening, but I'm going to hide the details for you for now. But that's an example of what you do when you initialize something. And you can also declare and initialize something on the same line. Okay, so I can go in there and I can say, another one. I'm going to say double height. Height is equal to 10.5, right? What I'm doing here is I am declaring and initializing the variable height to 10.5, and the variable height to be of the double type and equal to this thing, right? So that's, you're declaring it by saying, okay, it's going to be this name, and it's going to be of this data type, and initializing it, you're giving it some value. You're making it equal to something. Okay, the equal sign is known as the assignment operator. So this is the assignment operator. It makes the thing on the left equal to the thing on the right. That's basically it. Okay, unless I see some other stuff, and I'll show you that too. Okay, classification of variables. All right. So there's different kinds of variables. There's an instance variable, there's a class variable, there's a local variable, there's parameter variables. I will show you some examples of that right now. Right? So these here, these are examples of instance variables. Instance variables. Okay? These are my instance variables. If I go in there and I just do, I'm going to go in there, I'm going to say static double, I don't know, weight. Right? Now this here is an example of a class variable. I'll show you the differences of how they're different later. Okay, not right now. But basically, if he has a static in front of it and it's outside of all these other methods, it's a class variable. If it doesn't have the static, it's called an instance variable. And they have a difference, okay? Well, I'll tell you. So basically, the instance variables, okay? Every time I make an instance, so this is an instance, this room, right? So a room is an instance, right? And that a room has its own variables, these, right? It has a width, it has a length, it has a height. Okay, so that's an instance with its own instance variables. That means that if I make a room, I can change the properties of that room. So each room I make is going to have its own individual instance variables independent of the other rooms. So I change it if I change one room's instance variables, it does not affect the other room's instance variables. But the static one, the one that has a static, that's why it's called a class variable, that one belongs to all the object of that type. Okay? So every object I make is going to share that weight variable between all the other objects that exist. So if I change the weight in one of them, it changes it for all the other ones the same. They all stay the same with the same weight variable. Okay? So that's a class variable. Okay? And the other one is a local variable. What's a local variable? It's, let's say I want to go in there and I say, okay, int third. Okay, this is an example of a local variable. Okay? Local variable. Okay, what does it mean? Well, local variable, right? Local variable is declared inside of a method. Yes? So if it's inside of a method, it's a local variable. It belongs only to that particular method. I can't go in there and use it in any of these other methods. So it only belongs to this one. Only between the curly brackets of this one right here. Okay? So that's a local variable. Parameter variable, I'll get to that when I get to that. Okay? Because I don't know if I want to confuse you any more than that. Okay? Private, basically there's a way for you to restrict. So you can create different classes and you can tell them to hide their data by saying private. Okay? I pretty much noticed, if you notice, I'm not even using it. But in the book, you're going to see that they actually have, when they make these classes, they'll make it a public class, right? And then these variables here are going to be like private, right? So those are just a way for you to restrict how different classes see each other. For now, I'm keeping things simple. So there's no public, there's no private. They're kind of like optional. Okay? So that's that. Yeah, and that's basically the visibility, what can see what. Creating objects, I showed you, right? This is first, you can I've been doing it on the same line just like this, but you can do it on separate lines. You can declare an object, so this is declaring a variable room1 to be of the room type. This is actually called an instance, okay? Right, so this is instantiating a variable basically. So, and then this next one here is create an actual object can be referenced by the room1 variable. So basically, same as doing this whole thing here. New is referred to as the dynamic memory allocation operator, just like C++, we have a new in there too. Okay. The process of creating a new object is called creating an instance or instantiating an object. Memory leak in C++, we run into this issue. Like if you keep making up variables and pointers and all kinds of different things like that, you fill up memory, and your program can just keep sucking up memory until you run out of space, and then the things start crashing, or the operating system kills it. That's in C++, not in Java. Java's virtual machine takes care of garbage collection, that's what it's called, and gets rid of all these things so you don't even have to worry about it. The coolest thing about Java is, I personally think, it doesn't have pointers. So remember the little pointers and memory addresses and all that crap that's in C++? Doesn't exist. It just simplifies life a whole lot. Yeah. Okay, C++ has a single pointer, a double pointer, a left pointer, a right pointer, and then there's some other ones, and that wasn't enough. They came up with some other ones in the newest standard. Java said, forget all that stuff. We don't need pointers. And it works better, in my opinion. Okay? All right. So here we go. Now methods, constructor. So I got to tell you about a constructor. I'm almost done with this. The accessors and mutators. So first of all, the different methods. Accessor is the one that lets you look at things, right? And mutator is the one that lets you change things. So in here, which one is my accessor? This, right? This is an accessor method. Let me put the comments on top so it looks great. Accessor method, right? And this one here would be a mutator method, right? Same as this one here, right? So mutator method lets you change the properties of the object, right? These were the properties of the object. And the mutator, another mutator, change them against something else. Accessor mutator method lets you look at the variables, right? Lets you look at the variables. And the mutator method lets you change the variables. Okay? These are not the only two types of methods we could have. We can also have some other method right here, right? I made up some other method which calculates things. It's not an accessor, it's not a mutator, it does something else, right? So we're not just fixed to these two kinds of methods. Okay, and I already showed you about the assignment operators. I'll get to this in a second. Actually, I'll show you this first, and then I'm going to show you what a constructor is in Java, and then we're done. Okay, so first of all, this business here, let me just show you in the program. And I'm going to throw it in the main so it just happens all the way at the bottom. Let's say I have an int num, which is an integer number, right? And I'm going to say num is equal to 0, right? So this is, I am declaring it, declare, right? Initialize, okay? And then the next thing I'm going to do is, why don't I just show you? System out print line num equals, num. Okay? And then what I'm going to do is I'm just going to run this program real quick so we can see how it goes. Java C, room Java, Java room, right? Num is equal to 0. Okay. Now, if I go in there and I do something like this, I say num is equal to num plus 1. Okay? In math, this doesn't make sense, right? How can something be equal to itself plus 1? We're not checking to see if it's equal. Okay? We're assigning. So what I'm doing here is I am assign the old value of num plus 1 to num. So basically, this here is equal to its old value plus 1. So this is old value of num, which is 0. Okay? So if I do a system out print line, right after this, what value is it going to show me? 1, right? 0 plus 1 is 1. All right, I'm going to run it again. Oops. Here, compile, run, right? So it goes from 0 to 1. If I go in there and I say, all right, well, you're now equal to yourself plus 10, right? Now I'm saying same thing. Add 10 to your old value. So old value was what? It used to be 1 now. So it's going to be, now what I'm saying is I'm saying 1 plus 10, which is equal to 11. So if I show this again, I can save it, compile, run. Oops. I didn't do a system out print line after. Copy. There, save. Compile, run. Now it goes to 11. Okay, so that's the assignment operator. You're making one thing equal to itself plus something else. Okay, last thing, and going back here to this is a constructor. All right, what is a constructor? So that is the magical thing that makes things equal to 0. Remember when I run my program, remember how it starts things off at 0? That's the constructor. If you do not write a constructor, Java will write one for you, right? So let me show you an example of a constructor. So I'm going to throw that thing right here at the bottom. It doesn't have to be in any particular order. So constructor is used to initialize variables, right? If you don't write a constructor, Java will write one for you, right? And make all numbers equal to 0, right? And all strings equal to null. I don't know if it's capital null or lowercase null. Let's go lowercase. Right, so every string is going to be null, right? And every variable is going to be equal to 0. Okay? So this is why when I run my program, you're going to see these things. So there's zeros. Width is 0, length is 0, same here, right? So what I'm going to do now is I'm going to go in there, I'm going to redefine the constructor, the default Java constructor. How does the Java constructor go? It has the same name as your class. So it's the one method that has the same exact name as your class. So I'm going to go in there and how's it go? Must be public. Ah, it doesn't have. Well, I'm not even going to do the public, right? So I'm just going to do. What's the name of the class again? Room. Okay. So I go room. Ta-da. Okay. And inside this thing, I'm going to go in there. I'm going to say, okay, this variable here. That's a weird name, right? This one is equal to 100. And the other one, the length, is equal to 200. Okay, now when I save this thing and I go back to my program, you're going to see that when I first run it, it's not going to be 0, 0 because I overrode the default constructor. The default constructor in Java just does this. Okay, so what I'm changing is I'm changing that to this, saving it. I'm going to go back in there, I'm going to compile this, run it. Now look what it's doing. Now it's starting them at 100 and 200. Okay? So that's basically as far as I want to take it. Later on I'm going to add a little more to this. But these are the things that Chapter 2 covers. What's a constructor? It's a method which has the name of the class, which initializes the variables for you. When is the constructor called? This right here. See this? That calls the constructor. Okay? So now this demystifies a little bit of this whole thing, right? So this here, all right? This one here.
Oh, that makes sense.
Right? So this calls the default constructor. Okay? What the hell? Throw it. Man, I don't want to do it. I don't want to do too many things. Should I? You want me to add a little more? Or are we good? Actually, yeah, we're out of time, so I'll stop here.
All right.
Okay? But basically what you can do is you can throw in numbers in here. I can say, oh, well, I don't want to have 100 and 200 every time. I want to do like a 1 and 2.
Just for like a
You can change. You're going to have to change. I'll show you. So let's say so this is the default constructor. Default constructor. Right? And this is another kind of a constructor. Room, I'm going to call this int new width, and then int, where are the ints? Doubles, right? Double new width, double new length, right? And then in here I can say these are now equal to, this one is equal to this, This one is equal to that. That's the default constructor. So basically now, let me make another room. So I'm going to have room, C room, right? Third room is equal to new room. But I'm not going to use the default constructor. I'm going to use like 10 and 20, right? So these two values, I'm sending these two values into the other constructor. This variable here, the new width, becomes equal to this number. The second variable right here becomes equal to this number.
So it's kind of like a side constructor.
Yeah, it's like an extra different constructor, and you can have different kinds, many extra constructors other than the default. And then if I do, what was the method to look at it? I'm just going to look at this thing. So I'm going to say C room.L just to look at that thing, and you're going to see that that last one now is going to have the values that I just passed into it. And don't worry, there's like a section that covers more in detail what I just did, right? So, by the way, just for now, just so you know, these two, this, and this are called parameters, and the two values that we send over, right, this and this are called arguments, just like C++, right? Parameter arguments. Arguments are values we send into the constructor or method. Methods can do that same thing too. And my parameters are the variables which receive the, what is it? The arguments. The arguments values, right? Values. Okay? So these are the variables that are going to receive these two values. And then we're going to do more of that stuff next time. Okay? So let's have a look at what you have to do. Sample, class, program, and an exercise first. Okay. So you have some examples here. Let's see. Program submit, show operations, operator 2. Oh, I have them. Yeah, so type this thing up, get it to work, see what it looks like, put some comments in there after you get that program to work. Add something else to it and tell me what you added. So you have, I don't know, you have addition, I don't know, maybe add a couple extra numbers, maybe put an extra line, do another system out print line, right? Just do the basic stuff. So that's that. Yeah, it's something like this, right? You can just add a single line like this. I'll be happy with that, right? And then now write a new program, which is called this, that calculates and displays the results of the following this. So basically, just get these numbers, right? Create a new file, make sure it's called show operations 2, and plug in these values into this kind of setup so that it shows you different results. So it's not that hard. Next one. Creating classes. Okay. Type of the sample program below, room Java. Oh, there's another room. Right. So here's your sample, length and width. There's your constructor, default constructor, makes them equal to something. There's your mutator. There's your accessor. There's making the object and all good stuff. And by the way, type up all these comments so that you remember what's happening. Okay. And then I ask you to do add a mutator method to change the length to this, right? So in there I have a mutator method which takes two things and changes both things, and I want you to do another one which just takes one thing and changes one of them, right? So you could use that example and then just call that thing from the main so that you can see that it works, just like I have called this one here, right? So you're going to call yours with a single number. And then the next one is, last one for today, last one for the week, is type up the program below, including all the comments, right? Again, type up all the comments, right? And then, what do we do? So type this whole thing, get it to work. After it works, what are you going to do? You're going to add two new methods and call them from the main. One is decrement, which uses minus minus or minus 1. And the other one is decrement by. So you probably, I give you an increment. See how the increment does? So you have one property which is num, in here in this increment, I'm saying plus plus. Plus plus is the same as saying num is equal to num plus 1, so add 1 to its old value. And what you're going to have to do is just write one that's called decrement with a minus minus, right, instead of plus plus. Here's your example of increment by. So this thing takes a variable, another num, and it says num plus equals another num, which is the same as saying num is equal to num plus another num. So this is just a shortcut, right? Just like this was a shortcut for this. This is a shortcut for this. Okay? So you're going to have to do basically a decrement by. So it's the same exact thing. You're just going to change the name, flip the signs, and that's it. We're good? Any questions? Okay, so that's your mission for the week. Let me know if you have any questions. If you get stuck on anything, send me an email. And that's all.